So next of all, we have to talk about the fixtures unit. Like in our firefighting system, we have the one is called the sprinkler head factor. Same here, we demand a unit for our fixtures. That's called the fixtures unit. That's based upon the frequency of use, time of duration of use, or type of equipment. That means frequency of use means we have the water closet means only I think for a, if you have a 3%, maybe the six times you use in a 1 day, or if you have the laboratory, maybe 10 times. More, I think more than 10 times is not using that in laboratory. And obviously the laundry tray. Obviously we have the once in a day, but twice in a day. So that is a frequency of use. Then time duration of use. So what the time we using that picture. If you're using the kitchen sink, maybe kitchen sink maybe while take uh, 30 minutes to wash the dishes. What the number of dishes we have, that mistake time we have to take that. And water closet and urinals probably take less than 1 minute. And bad it also. Then first big laundry trays. So that's the frequent. That's the time duration of use. Then type of occupancy where we using this. Where is the fixtures unit belongs to? We have the general area pictures and bathroom pictures and the kitchen pictures. According to these types, we gave a number. That one is called the our pictures unit. And now the fixtures unit is again divided into two types: supply fixtures unit and the drainage fixtures unit. That means we have a the fixtures unit have the drainage and supply. Some units have only supply and some units have only drainage. Some units have the both. And the supply water again is divided into two: cold water fixtures unit and the hot water fixtures unit. So they are representing the abbreviations for the short keys or the short words as in short words. We can say the fixtures unit, supply fixtures unit is as WFU, water fixture unit, water fixture unit. And DFU, it's for a drainage fixtures unit. And again, WFU divided into two: CWFU and HWFU. CWFU means cold water fixture unit and HWFU means hot water fixture unit. You need a basic idea which fixtures units they supply cold and hot water. Obviously, I can say uh, my lavatory. For a perfect example is lavatory, shower head. Shower head can provide cold and hot water. So based upon that one, the fixtures unit will and roles of the fixtures unit. If there is a no hot water supply, that means the whole building is full of cold water. There is no heater, nothing is present over there. So we can take the fixtures unit is equal to WFU. You see this in the plumbing table. You can see this is the WFU. WFU means water fixture unit. So take this one for an example. As an example, bidet. For a bidet, water fixtures unit is 1, and in your building, you don't have any kind of hot water. So that means cold water fixtures unit is equal to WFU. There is no difference. There is no hot water is present over there. So that means CWFU is equal to WFU. That is the first rule. If there is a no hot water, so that means cold water fixtures unit is equal to WFU. Then, if there is a both cold water and hot water supply, then cold water fixtures unit is equal to hot water fixtures unit. So that means if you take WF is 1, consider bidet for the bidet or bidet is. For a bidet, the WFE is 1. WFE is 1 for bidet. WFE is 1. Then the building have a cold water and hot water supply. That means our cold water fixture unit. You can see here the cold water fixture unit. How can we take the cold water fixture unit? Means the cold water fixture unit and the hot water fixture unit will be the 3 by 4 of that water fixture unit. Example, WFE is equal to 1. For an example, we can take pilot. Then the CWFU is 0.75. If, take us as an example, bathtub. Bathtub WFE is 2. Then the cold water fixture unit and the hot water fixture unit will be the 3 by 4 of 2 because the water fixture unit is 2. So that means 1.5. The hot water and the cold water become 1.5 each. Here the water fixture unit is 1. Therefore, the CWFU and the hot water fixture unit, that means cold water fixture unit and the hot water fixture unit became 0.75. And this is the basic rule. CWFE plus HWFE is not equal to WFE. That is the main thing. If you add 0.75 plus 0.75, you will get 1.5. And the WFE is 1. So that is not equal. So that is the fixture unit. You have to, there is a rules of fixtures unit. And this is the idea. One second, guys. Okay. Look here. The cold water in is CWFU. For laboratory, if you have two type of water you need. The cold water fixture unit, the flow rate will be 1 GPM. Then the flow rate and the pressure rate will according to that fixtures unit. if we have the two types of water, that means cold water and hot water, so the GPM, the flow rate, and the pressure will be the different ways. That's the way is saying this one. And you have to find. Next is a problem. Find out the fixtures unit and flow rate for an apartment building that has 25 water closet, 25 hose beam, 20 shower head, 10 BT, 15 KS, 5 LT, and 2 dishwasher and 5 SC. Okay. The first one. So what are the fixtures we have? Water closet, the flush tank, We have to find out the CW. CWFU is equal to W. First, you have to find out water closet plus tank. Tank type and it's a private. W. So WF is 5. Private tank type. Here is cold water fixture. That means cold water only present over here because they already said there is only a cold water supply. The building has only cold water supply. So we don't have to worry about that hot water. So WF is equal to CW. Next one, hospital. Hospital is here. Hospital and horse is private. Hospital 3. One more thing. Here you have to 5 multiplied with the number. Actually, we have a hospital. Into now shower head. Let's take that. Shower. Yes, shower. Shower is 2. Then the bathroom. 2 into 10, 20. This 2 and the 10 feet. Then kitchens. Kitchen sink with the grinder is 5. 2 into 15, 30. That means each kitchen sink have that water measure unit is 2. And I have 50. Because what I am doing is I am going to find out the total flow rate for that building. That's why I have to find out all the water mixes for that kitchen sink, wherever they present in that. And laundry. Laundry. Right. Then dishwasher. Domestic. 1. Then the silk. Silk and wash we have the same. So 3 into 5. Then laboratory. Laboratory private. 1. 1 into 20. 20. Then add the size code. These are the size code pressed over here. So you add that one. Yeah, find out this. Then individual flow rate. Individual flow rate is here. Individual flow rate for that heat just is flow rate. Stands for rate. What I need means 337. 337 GPM. Sorry, not GPM. The just 337 pictures unit, and using this table, page number 37. Sorry, 7. These are the water supply fixtures unit. But because if you using this table, this is for the individual flow rate. That means if you draw the pipeline from the each pipeline, each fixtures need their own pipes, so that uh, that flow rate is defined over here. So that's the only thing I don't need here. I need the total flow rate. If I want to find out the total flow rate, I need the full fixtures units. I need full fixtures units. Then come to that page number 7. This is the total flow rate. This is the water supply fixtures unit. If I have a 337. Where is a 337? The fixtures unit is here. And 337 is right here. There is no 337. After 300, that's a 400. So take 400. Then no need the flush meter tank type water closet. Take tank type water closet. So for a 400, you need 47.7 GPM, gallons per minute. Gallons per 300. Understood? This is they need. In a minute, they need 47.7 gallons. First question. And the second question is for you guys. Water fixtures unit, hot water and the cold water. We have the time. Just do this one. Nothing. First of all, you have to do the water fixtures you have to write down. Then the numbers given over here. Then find out the water fixture unit. Then multiply it with the number. Multiply it with the number. Here they don't need that actually. Water fixture unit. Then don't multiply the number. Fixtures, number, water fixture unit, then 3.7. 3 by 4 of that water fixtures unit. Then take the total one or multiply it. 3 by 4 of that water fixtures unit. If the fixture have the cold water or the hot water. Water closets doesn't have any kind of hot water and cold water. Only they have cold water. Hospital doesn't have that hot water. Only shower head, bathtub, kitchen sink, dishwasher, laundry tray, and lavatory have that hot water and cold water. These are the one. Next one, the feed systems. Up feed systems and the down feed system with the OH. Here you can see the municipal water upward system means we take the municipal water supply from our municipal line. Then through the water meter, we push that line to our feed. That one is called the upfeed system. Second one is the upfeed and the downfeed system with the OHT. OHT means overhead tank. Municipal supply have our municipal corporation have that municipal line. From that line, we took our line to our building. Obviously, you need a certified plumber for that connection actually. You have to give that money to that plumber actually. If you want to take the license for that plumbing line, you have to take like that. Then the water will go to my overhead tank. The overhead tank we put on our terrace. That one is called overhead tank. From that tank, we took our, then the water will go to our fixtures. So this is the basic idea. Think about it. In our normal homes or anywhere, municipal water, there is no municipal water. There is a well over here. So from that well, we using the pump to suck the water, then fill the water to my overhead tank. Then we will give water to my fixtures. That is the familiar system we know, except the municipal water supplies. And upfeed system with OHT, UGT, and transfer pump. Here we having, look this one, upfeed system and downfeed system. The municipal water supply and the water meter. And the water will store in your underground tank. Because in the normal municipal water, they will distribute water twice in a day or once in a 4 day. So that is the time duration they have. So the underground tank is actually act like a storage. For 4 days, it will store the water. And the overhead tank will store the water for 1 day. If the municipal supply is once in a 4 day, you have to calculate the total water demand in a 1 day. Then that is the capacity of overhead tank. Then multiplied with the 4. That means we supply once in a 4 day. I have to store the water for 4 days. That means the UGT capacity is 4 times than overhead tank. So that's the idea here. Then we have the booster pumps, transfer pump and the booster pump. UGT obviously have that transfer pump because we need that pressure, build that pressure, suck the pressure and discharge it. Then we have that booster pump. If you're lacking that pressure, sometimes our pipes and our fixtures doesn't have that pressure, we accept it. That time we use the booster pumps. Hydropneumatic system. We have the pressure switches and our two pumps use the water. And centralized hot water system. Our hotels or malls or everywhere, wherever you need the hot water, obviously you need a centralized hot water system actually. Not only our home, I say the large commercial buildings. The underground tank will store the water. Normally, the cold water supply, CWS, cold water supply. And we have the fixtures needed cold water supply. Normally, we using the pump to push that water to that fixtures. But here, sometimes you need the hot water. Water heater is present over here. And the water heater is connected to like a copper pipe or any other thing. Then we use a pump. After the cold water is went through that water heater, it became hot water. Then the hot water and the pump start to push. Then it will go to my fixtures. Think about it. Either 5-star hotel, if the client open the tap or whatever the fixtures they open, they need the hot water certainly. They need instantly. They need that hot water. There is no waiting for that hot water. So that time we have to keep every time the hot water in that line. But if the client is not used, eventually in that copper pipe, our water is staying. After some times, the heat will transfer. So obviously water will loses the heat. Then we have another trick. We will collect that pond, collect that loses temperature lost water, then collect it to my storage tank. Again, we will do a loop structure. So it's a loop-like structure thing. So this is the thing for centralized hot water system. Now we have the one Overhead tank capacity, maximum water demand, UGT. Underground tank capacity, overhead tanks capacity into time delay between water supplies. That's the thing I am saying. Overhead tank capacity into time delay between water supply. Plus, we will take the 20% factor. And water heater capacity is equal to total hot water demand in GPH, gallons per hour. Then demand factor, that thing we will. Yeah. So this is the question. Find out the UGT and the OHT capacity for an apartment building that has 50 individual apartments, each with a 5%. The building has garden area of 2000 square feet. The building also accommodates a swimming pool of 400 square feet area which have 10 people at a time. The building has only cold water. Then you have to find out the UGT and OHT capacity. So using this one, first of all, daily water demand for a person. Looking this table, there was another table. So the water demand. Apartment for a resident. Page number 8. Apartment. Apartment, one person need 50 gallons. One person need 50 gallons. Here you have how many? 50 individual apartments into 5 means 50 individual apartments and 5 persons. Each person's needed 50 gallons. Total 12,500 gallons for that people. Next, it's a garden area. We have it has 2,000 square. Now find out the garden. Yes, lawn and garden. Per thousand, you need 600. I have 2,000 square feet. Per thousand, you need 600. Yes. Means oh. Next one is yes. So next one is for pool. 400 square feet. There is a pool, page number 9. Yes, swimming pool. Per swimmer is for 10. Per swimmer is 10. Yeah. Per swimmer. How many swimmers I have? 10. 10 people at a time. So 10 into 10. 100. 10 into 10. 10 into 10, and they one say per 100 square feet. Per 100 square. So 10 into 10 is for 100. I have 400 square feet. So that means 100 for 100 square feet. That means look this one. 10 simmers I have. 100 gallons for the 10 simmers. And it for 100 square. I have 400 square. What will you do? For 100 square feet, I have 100 square feet. That means 4 into 100. 400. 400 gallons. Now, oh, so these are the one. Nothing more. Now, add these ones. Fourteen hundred GPD. 1400 GPD I needed. So that is the OHT capacity. 14,100 gallons is for my OHT capacity. Then have a, what is the time delay? So once in a 4 time for a OHT capacity. Multiplied time delay, then multiplied with the 20%. Plus 20% factors. Plus 20% factors. That is the gallons for UGT capacity. That is the UGT capacity. Then next we have to talk about that water heater capacity. Water heater capacity. To find out this one, go with that table. Yes. So for an apartment building, you have to write down the pictures and number. Then here you having the hot water demand. For a lavatory, apart for an apartment building. You have apartment building, right? Then number, then multiply with the number. It means picture. Hospital, obviously, hospital and water closet you can find out in here because water closet and hospital doesn't have any kind of water. Sorry, hot water. First of all, you have to write down the lavatory. Lavatory. For a lavatory, that's a 2 is that water demand. 2 into 20. That is the hot water demand. That is for next. Then add that total. Add that total. Add that total. Add that total. Then What total hot water demand into demand factor. This one is called that demand factor. We can see here for an apartment, this is the demand factor, 0.3 multiplied with the 0.3. Then you will get the water heater capacity. Then the storage tank capacity. Storage tank for that water heater. Water heater capacity into storage capacity factor. Here they given here 1.2. Then you will get that water heater capacity. Okay. Okay. Will do. Okay. Tomorrow. Any doubts? Any doubts? Okay. So fine. So see you tomorrow.